Hello and welcome to ZacBowFitness. So this is the second video looking at macronutrients. Last time we looked at carbohydrates, today we're going to look at protein. Before we look at the protein, let's look at the macronutrients. So you've got carbohydrates, which you'll see, I did a video the other week, so if you've not seen it, check that out. Today we're going to cover proteins, and in a couple of weeks I will cover fats. So let's look at the functions of proteins. Protein belongs in a group of organic compounds that serve many functions in the body. The types of protein within the body can be placed under three main headings along with their function. So here are the three headings underneath: structural, homeostatic, and fuel. Proteins are essential for the growth, maintain, and the repair of the body tissues. Protein is a major part of every living cell and most tissue, such as skin, muscle, hair, nails, and the core, bone, and teeth. They'll also have a structured role and physiology function in the body, such as hormone production, production of antibodies by white blood cells to help fight infection, provides an energy source for the body, although not a primary function. So if you remember in the last one, we said carbohydrates and fats were the main ones, and protein is only used when there's a lack of carbohydrates. So that's something to think about as well. So when you're looking at it there, so as you can see there, so it helps hormone productions, so all the different hormones, and then obviously antibodies for the white blood cells to help fight infection. But let's look at the structure. Proteins are made up of building blocks called amino acids. There are 20 individual amino acids in total, and different combinations of these individual amino acids make up the protein that is used within the body. Animal and plant cells join together to form peptides. These peptides are made up of a chain of varying lengths and types of amino acids, which eventually become proteins. Proteins are formed when two or more polypeptide chains combined and linked together to form three-dimensional shapes. The shape and the structure of these combinations will detect the function and the role of the protein within the body. Let's take a look at the amino acids. The 20 amino acids can be split into two groups: essential amino acids and non-essential amino acids. So let's look at essential amino acids. Of the 20 amino acids, 9 are considered to be essential to our daily diet, as our body is unable to produce them, which means they need to come from our diet and the food we consume. Non-essential amino acids, the remaining 11 of the 20 acids, are classed as non-essential, not meaning that they are less important. They are also present in many of the foods we consume, but not always required as part of our daily diet. As long as the 9 essential amino acids are present, our body is able to synthesize or produce these 11 non-essential amino acids, hence non-essential. So as you can see, like when we talk about getting your daily diet and people talk about amino acids for recoverment, so obviously you look at the different types of protein you're having and that kind of thing. So we draw it off the proteins, helps your body recover when people talk about the amount of protein you have to build muscle in that. So as you can see, the structure with the essentials and the non-essentials. So let's look at protein sources. So what we'll start is with complete proteins. These are the foods that contain all 9 of the essential amino acids in sufficient amounts for the body in the liver to synthesize and produce the remaining 11 non-essential amino acids. The majority of the complete protein sources are animal-based foods, although there are some experts who claim that there is a few plant-based complete protein sources, such as soya, buckwheat, and quinoa. So let's take a look at incomplete proteins. Plants also contain protein. However, these proteins are of low biological value and they are deficient in one or more of the essential amino acids, making them incomplete. As plants often contain small amounts of protein, it is difficult to consume enough protein and amino acids from these plants products solely. So when everyone thinks of protein, everyone sort of thinks of chicken and like meat-based products. So like when people say you should have protein with every meal. So when I was in Thailand, we was having chicken with breakfast, which seemed a bit weird at the time. So it was having like a low-carb breakfast. So it was mainly sort of like salady with avocados, but chicken, because we was told it's best to have that kind of protein with every meal. And as you can see from the other side of it, the complete proteins, that would have had, the chicken would have had all the amino acids that we were needed, unlike if we was eating veg-based stuff. So yeah, so when you look at it, when you've got to look at the value as well, you've got to look at the protein value of what you're eating. So let's look at complementary proteins. As plant-based protein is incomplete, it is recommended to vary and combine plant-based protein sources to help provide the full range of essential amino acids. Not only is it vital for vegetarians, but it's also good for meat and diet variant for meat eaters, and to reduce the amount of saturated fat contained within animal-based products consumed in the diet. Good varying or combining with combined plant rate produces that, when consumed together, provides the 9 amino acids. Now, here is an example. So rice and pulses, vegetables and seeds, nuts and vegetables, grains and pulses. So these are the ones that you combine together to try and get your 9 amino acids that obviously don't come with the plant-based, in the incomplete side of it. Let's look at protein requirements. As protein forms the majority of the cell structure within the body, it is essential that the adequate protein is consumed within the diet to ensure health and performance is maintained. The amount of protein required varied from individual to individual. It depends on their activity level and their health and the fitness goals. It can be difficult to get the amount of protein right in such to be a main component of each meal, but it commonly only consumed as part of the evening meal. So like I said, when I was in Thailand, we was advised it would be best to have protein in the morning as well, but chicken. So like I said, it was weird to have chicken for breakfast. So as you can see, they say that the majority of it. So a lot of people will maybe eat it at lunchtime as well. They'll have a sandwich with maybe chicken in it or ham or that kind of stuff in it. So we do it in a way, but mainly our main meals in the evening are set, if you're a meat eater, around a protein based. So when you look at it that way, so what they're saying is that really you should have the protein in your breakfast, lunch and dinner to make sure you are getting the right amount of protein for your body. So you can always work it out, like it you show at the start, where it says how much of what the breakdown is of carbohydrates, protein and fats. Everyone will be different. Like I said in the last video, some people will be eating higher carbs or lower carbs, staying around the same proteins, but might be having a lot more fat. So I hope this has helped with the protein stage of it all. Don't forget, subscribe if you haven't already. Put your comments down below if you have any questions about the video or anything like that. But don't forget, hit subscribe, and thanks for watching. Don't forget, check out the one on carbohydrates, and in a week or so I will do the last one on the macronutrients about fats. Take care, people. Get out training, or whatever you want to use it for. If you're using it for healthy stuff, just looking at diets and that. If not, get out training, get building that muscle, getting fitter. Excellent, people. Take care. But don't forget, subscribe. Check out my Instagram page and check out my Facebook page. Excellent.